Now in order for me to get the bulbs out of this SX-440 receiver, I got to go ahead and figure out what's holding this thing here. I can see they put some type of a compound here to fix the bulb and the bulb holder to the frame here. Now in order to get the bulbs out here, I'm checking out the situation, which I really can't do without this mirror underneath here. To see they got some kind of white compound here fixing the basically the bulb holder to the frame here, and it looks like that compound's probably seeped underneath there too. I probably can't scrape that free, so what I'm going to do, I think I should be able to, you can see there's a slit down here. If you look directly at the mirror, I think I can get a screwdriver up underneath there and then pry that open and pull the whole lamp assembly with the lamp out, bulb assembly with the bulb out. So let me try that. So I'm just going to try to take a, I can't see with the camera in the way now, which is a headache, so I'm just going to go ahead, maybe I can do it if I can get this flathead screwdriver underneath there, and then try to pry this open carefully. And also on the other side, I have to shut the camera off because I can't get in there. Now progress is happening. I had to use a bigger screwdriver, and what I did is simply pried it up underneath here. I'm going to try to do a minimum amount of prying, of course, until I break this, the whatever, that adhesive here, or paint or something, whatever is holding that. Paint is like glue too. Oh, well, there she goes. Now here's the exposed basically bulb holder, lamp holder, and the bulb here. There's really no need to tear all of this apart here, like with these insulating washers on there. And what I bent here, I don't know if that can be seen here, I don't think so, like right up there, it's barely bent. That can be easily bent back, and then I can fix that with like fingernail polish. Now I have to get the bulb out, which has been in there forever. I'm going to try to turn it out first. I'm going to put a pair of gloves on in case the glass breaks, and then if it does, I'm going to go ahead and use a pair of pliers and try to turn it out. And here's one of the bulbs. It says Stanley on there, 6.3 volts, 0.25 milliamperes. So next I'm checking for DC voltage at the speaker outputs. I'm not supposed to have any, and if I do, there is a problem. I simply put the meter in the DC voltage position and just measure across the, here, this is the ground side, and here is the signal side. And if I look down on my voltmeter, what do I get? I'm getting 0 volts DC, which is as it should be. Here, this is a little bit different kind of power amp design here. It doesn't use a dual supply, positive and negative. Rather, it just uses a positive supply, and at the midpoint between the two output transistors for each channel, there's supposed to be half of the supply voltage. So basically the signal path is from the transistors here over to these capacitors, through the capacitor, and then to the speaker terminals. So again, I said I should be reading about half of what the power supply voltage is for this power amp here, and I'm reading right now. What am I reading? 0.9. Why is that? Okay, I don't have the unit on, that's why. So turn it on, and we can see here what we're getting. So right now I'm about 18.4 volts, so that stands to reason the power supply voltage is around 37 volts, and this would be half of that. The same thing with the other channel. If it's off, then I know there's some kind of an imbalance. Then I'm going to have to start checking components and see what's causing that. Now here's the other channel, which is about the same thing, so I venture to say everything's okay. Now here where I put this red X, this is that midpoint or halfway point I was talking about. Say if your supply voltage was right here, say 34 volts, and right here you should be reading half of that, which is the 17 volts. You can see here this is the output transistors for one channel. Here are the emitters tied to the collector, and there's that capacitor I was talking about. And if we follow this over here, you can see here goes to the speakers. So that's a little bit different than with the dual supply unit that has a positive and negative power supply. Here are the two idle current adjustments. These are held in place by some kind of paint here. So I've already broken these free and I've been twiddling around with these. But what I want to say is I have a service manual, but there's no mention of any kind of adjustment for whatever reasons. And since these can be put in two extreme positions, like if all the way over here to the left and then all the way to the right, and two extremes basically. I think one you would have zero idle current and the other one would be the maximum position. I think probably the setting is probably going to be somewhere like halfway in between those two extremes. And this here, these resistors here, it looks like you have to put your voltmeter across these here. Of course, again, there's two adjustments, one for the left channel, one for the right channel. So what I'm going to do is just basically hook up a voltmeter of course in the DC position just across here, and then see what kind of a reading I get then. So I got it, got the voltmeter in the DC position across the resistor, and I'm going to go ahead and do a little turn on here. Normally I have to wait a couple minutes to get this thing to warm up, but see what we got. 0.235. I'm going to go ahead and turn this thing all the way down. I'm turning it now, it's just hard to do. Yeah, I can get it all the way down, and well, I better put it back up to where it was, that's a fact. Let me get the oscilloscope and hook up the oscilloscope to the outputs first. So right now I'm feeding in a triangle wave, and if I see any type of crossover distortion, it would be right here at this halfway point, right basically at your how would I call this now, basically your zero baseline here. If you can imagine, here's a positive side, here's negative, positive, negative, and then it would be right here in the middle somewhere. So I got to hold the camera with one hand, and I'm going to go ahead and manipulate now this idle current control. Okay, something's happening here. See, that bar is really thickening up. That's not, you know, it's turned all the way down. It's almost like some kind of a hum bar or something like that. So let me go ahead and try something else. Let me just use a regular sine wave. Now here's a regular sine wave. What am I feeding in? It's 1,000 hertz, I believe. Okay, right there, that's a bad connection right there. Okay, this here, you can see this thickening there. You know, that would be definitely in the wrong position. I wonder how that sounds like if I would hook it up to a loudspeaker. And this is going to the other extreme, and here I'm turning the idle current all the way down. So it definitely cannot be in that position, because look at that sine wave there. Now we go ahead and try to go up in frequency. I'm going to take this thing up to like 20,000 hertz. There, I'm up 20,000 hertz now. Now I'm going to see. This might be easier to see now. Yeah, you can see right there. In fact, right there, it's starting now. You can see that sine wave is not correct anymore. If you look at the tip there. Okay, that definitely is not the right position to be in. Let me go to a square wave. Ooh, how does that look? I think I might have to fiddle around with the tone control. Well, that's a 20,000 hertz square wave, so that's really going way out there. That's even testing out to 20,000 times 10, 200,000 hertz out there. So that's why here, that means high frequencies lacking that little rounded off edge. But that wasn't what I was talking about. I want to see what yeah, you can see what that does. So that's definitely not the right position to be in. So I think I'm going to do just park both of those potentiometers midway between both of the extremes, and I'm just going to go ahead and leave it at that. So anyways, I've been listening to music and twiddling around with the bias controls here and see if I could hear a difference, and I don't. I guess my hearing must really suck. So I think that would basically conclude this video. I think originally what was supposed to be wrong, have been wrong with this thing, I think there was something with 1 or 2 channels, but it seems to be more like, because it uses these odd old style speaker terminals, I think it was more or less a connection problem is what it was. Which reminds me, I think I gotta spray some contact cleaner in speaker terminals, and I might even swap these out down the road if I decide to keep this unit. I think there's a bigger unit, the SX, I think it's a 770, and then there's the SX-990, but I'm not sure. I'm gonna go ahead and try to get those other 2 units too, and keep that in my collection. So I think this is about it for now with this unit. I've got more projects to work on. Thanks for watching.